let's say I have the point 3 comma negative 4. So that would be 1, 2, 3, and then down 4. 1, 2, 3, 4. So that's 3 comma negative 4. 3 comma negative 4. And I also had the point 6 comma 1. So 1, 2, 3, 4, 5, 6 comma 1. So just like that, 6 comma 1. In the last video, we figured out that we could just use the Pythagorean theorem if we wanted to figure out the distance between these 2 points. We just drew a triangle there and realized that this was the hypotenuse. In this video, we're going to try to figure out what is the coordinate of the point that is exactly halfway between this point and that point. So this right here is kind of the distance, the line that connects them. Now, what is the coordinate of the point that is exactly halfway in between the two? What is this coordinate right here? It's something, comma, something. And to do that, let me draw it really big here, because I think you're going to find out that it's actually pretty straightforward. At first, it seems like a really tough problem. Gee, let me use the distance formula with some variables. But you're going to see it's actually one of the simplest things you'll learn in algebra and geometry. So let's say that this is my triangle right there. That is my triangle right there. This right here is the point 6 comma 1. This down here is the point 3 comma negative 4. And we're looking for the point that is smack dab in between those 2 points. What are its coordinates? And it seems very hard at first. But it's easy when you think about it in terms of just the x and the y coordinates. What's this guy's x coordinate going to be? This out here, this line out here represents x is equal to 6. This over here, let me do it in a little darker color. This over here represents x is equal to 6. This over here represents x is equal to 3. What will this guy's x coordinate be? Well, he's going to be his x coordinate is going to be smack dab in between the two x coordinates. Right? This is x is equal to 3. This is x equal to 6. He's going to be right in between. This distance is going to be equal to that distance. His x coordinate is going to be right in between the 3 and the 6. So what do we call the number that's right in between the 3 and the 6? Well, we could even call that the midpoint. Or we could call it the mean or the average, or however you want to talk about it. We just want to know what's the average of 3 and 6. So to figure out this point, the point halfway between 3 and 6, you literally just figure out 3 plus 6 over 2, which is equal to 4.5. So this x coordinate is going to be 4.5. So let me draw that on this graph. 1, 2, 3, 4.5. And you see it's smack dab in between. That's its x coordinate. Now, by the exact same logic, this guy's y coordinate is going to be smack dab between y is equal to negative 4 and y is equal to 1. Right? It's just going to be right in between those. So this is the x right there. The y coordinate is just going to be right in between y is equal to negative 4 and y is equal to 1. So you just take the average. 1 plus negative 4 over 2. That's equal to negative 3 over 2. Negative 3 over 2. Or you could say negative 1.5. Negative 1.5. So you go down 1.5. It is literally right there. So just like that, you literally take the average of the x's, take the average of the y's, or maybe I should say the mean to be a little bit more specific, a mean of only 2 points, and you will get the midpoint of those two points, the point that's equidistant from both of them. It's the midpoint of the line that connects them. So the coordinates are 4.5, comma, negative 1.5. Let's do a couple more of these. These actually you're going to find are very, very straightforward. But just to visualize it, let me graph it. Let's say I have the point 4, negative 5. So 1, 2, 3, 4, and then go down 5. 1, 2, 3, 4, 5. So that's 4, negative 5. And I have the point 8, comma 2. So 1, 2, 3, 4, 5, 6, 7, 8, comma 2. 8, comma 2. So what is the coordinate of the midpoint of these 2 points, the point that is smack dab in between them? Well, we just average the x's, average the y's. So the midpoint is going to be the x values are 8 and 4. So it's going to be 8 plus 4 over 2. And the y value is going to be, well, we have a 2 and a negative 5. So you get 2 plus negative 5 over 2. And what is this equal to? This is 12 over 2, which is 6, comma, 2 minus 5 is negative 3. Negative 3 over 2 is negative 1.5. So that right there is the midpoint. is the midpoint. You literally just average the x's and average the y's, or find their mean. So let's graph it just to make sure it looks like the midpoint. 6, negative 5. 1, 2, 3, 4, 5, 6. Negative 1.5. Negative 1, negative 1.5. Yep, looks pretty good. It looks like it's equidistant from this point and that point up there. Now, that's all you have to remember. Average the x, or take the mean of the x, or find the x that's right in between the two. Average the y's. You got the midpoint. What I'm going to show you now is what's in many textbooks. They'll write, oh, if I have the point x1, y1, and then I have the point, actually I'll just stick in yellow. It's kind of painful to switch colors all the time. And then I have the point x2, y2. Many books will give you something called the midpoint formula, which once again, I think is kind of silly to memorize. Just remember, you just average, find the x in between, find the y in between. So midpoint formula, what they'll really say is the midpoint. So maybe we'll say the midpoint x, or maybe I call it this way. I'm just making up notation. The x midpoint and the y midpoint is going to be equal to, and they'll give you this formula, x1 plus x2, x2 over 2, and then y1 plus y2 over 2, and it looks like something you have to memorize. But all you have to say is like, look, that's just the averaged or the mean of these two numbers. This is just the average or the mean of these two numbers. I'm just saying I'm adding them to the two together, dividing by 2. Adding these two together, dividing by 2. And then I get the midpoint. That's all the midpoint formula is.